Much, and welcome everyone to today's event on a pragmatic approach to DevOps and the mainframe. It's interesting to me that you seldom hear the words DevOps and mainframe used in the same sentence. The graphic on this slide shows one reason why this is the case. For those who spent time in data centers, a lone computer operator sitting at the console is a familiar figure. And while there's nothing wrong with this per se, since obviously mainframe skills are critical, when we think about DevOps, we're usually picturing something very different. Collaboration is at the heart of DevOps practices. So how do you reconcile the two worlds? During this event, I'll talk about the impact of DevOps on modern IT practices and its role in business success. I'll discuss the realities of mainframe usage in both large and smaller companies and the challenges they encounter in rolling out and supporting mainframe-centric applications. Next, I'll talk about tools and their importance in bridging the traditionally very different worlds of mainframe and distributed application support. Finally, Jim and Spencer will talk more specifically about the role of tools and discuss Compuware's answer to DevOps on the mainframe. So what is DevOps? Well, to start out, I'll tell you that while we're hearing a lot about DevOps lately, it's defined differently by virtually every analyst and vendor. From my perspective, DevOps isn't simply a set of processes that kick in when software is deployed. I believe it's more productive to view DevOps as a combination of the skills, processes, and tools necessary to enable IT professionals with diverse skill sets to collaborate as necessary across the life cycle. IT needs the skills that exist in technology silos. However, simply delivering servers and databases is only part of the big picture. From the business perspective, the entire purpose of servers and databases is to provide a foundation for the delivery of applications supporting key business functions. And when you approach DevOps from this top-down business-focused point of view, collaborative processes and practices become a cornerstone for IT business alignment. So what actually are some DevOps-related benefits? Well, the first is that DevOps processes provide a blueprint for the cross-silo bridges necessary for efficiently supporting applications, since applications also span silos. In addition, focusing on applications versus infrastructure, as DevOps practices do, provides a basis for faster diagnosis and resolution of production issues which may occur. Next, DevOps provides a framework for delivering new software faster and more efficiently. Companies in almost every industry report that the need for speed is more pronounced than ever before. Industries and technologies that drive them are changing at an astounding rate. Businesses must adapt or die, and software is a big part of that process. This means that continuous delivery of new features to production is becoming increasingly important to the business. And improved efficiency at any stage of the process can compress delivery times by making the entire life cycle more efficient. In fact, my latest DevOps research is showing that the quality of the interactions between Dev and Ops can actually impact revenue growth. Companies reporting above average or better day-to-day interactions between Dev and Ops are 6 times more likely to see double-digit year-over-year revenue growth than those reporting average or below interactions. And as you can see here, while it's certainly possible to grow revenue without successful DevOps interactions, the likelihood of doing so is far smaller. This drives home the fact that software has become a key enabler, which allows businesses to more flexibly adapt to market pressures. Disruptions such as government mandates, new technologies, and the economy in general have slammed businesses in recent years. These changes drive home the need for agility in adapting to these outside influences. So I've talked about DevOps. Now let's talk for a few minutes about the mainframe. Is it really still relevant, or are the rumors of its demise actually true? Far from being irrelevant, the mainframe is more pervasive than Linux, private cloud, or middleware when you look at companies across the board. It far outstrips the LAMP stack and Hadoop, which are all over the news. And interestingly enough, mainframe usage is not confined simply to the highest echelon in terms of company size. The percentages are relatively similar in mid-sized and enterprise-sized companies, and even smaller companies may well have a few massive applications which simply cannot run on less powerful systems. So mainframe use is not confined simply to the Fortune 50s of the world. How's it being used? Well, this slide breaks down usage numbers by a number of different application deployment architectures. First, note that the mainframe is a component of all these transaction types in almost 20% of the companies responding to my latest survey, and they're shown here as the orange bar. Next, when you look at application categories which are typically not considered to be mainframe related, such as tiered, distributed, and hybrid applications, the mainframe is still a key player. In fact, distributed transactions accessing the mainframe are 3 times more prevalent than those which don't. In addition, twice as many hybrid cloud transactions, defined as executing across on-premise and public cloud, access the mainframe than not. Finally, the mainframe-only applications typically associated with the platform are the least common deployment type. So it appears the rumors of the mainframe's demise are not only premature, they're actually totally untrue. These numbers separate fact from fiction in terms of mainframe applications, and they debunk many of the fallacies typically associated with mainframe usage. Mainframes are not simply standalone platforms running COBOL applications from 1972. Not only is the mainframe still relevant, it's an essential element of many complex modern applications. From the DevOps perspective, however, these numbers generate as many questions as they answer. How can cross-domain teams interact with mainframe operations when team members have minimal or non-existent mainframe skills? And how can IT organizations manage these mainframe-centric distributed applications, since many of the application performance management products on the market don't support the mainframe? Too often, the mainframe operator is viewed as the wizard behind the curtain, And once execution is handed off to the mainframe by an application, it then becomes a black box. Those outside the walls of the data center have no real way to determine its impact on the performance or availability of the applications that they're tasked with supporting. So they're trying to support the applications, and they have no visibility to a lot of the underlying functionality. In examining these questions, let's first back up a bit and look at the day-to-day life of these application support professionals. Looking at applications as a whole, not just those touching the mainframe, these are the top challenges application management support professionals cite across a number of surveys. Poor performance, intermittent problems, and high fixed costs always seem to top the list regardless of whether the mainframe is part of the mix or not. Distributed applications are fragile. They're massively interconnected, network-centric, and they depend on many different infrastructure elements. So there are also multiple potential sources of failure. For most companies, troubleshooting these types of applications is still a long, drawn-out process. IT specialists lack the visibility they need to many of the changes that occur in hardware and software elements, and the tools in place are often inadequate to support the complexity of the execution environment. It's very often the case that the tools have a partial view but not a full view of application execution. As a result, many problems go unresolved since the troubleshooting process simply takes too long to be practical or viable. This in turn contributes to ongoing problems. It's a never-ending cycle with unsolved application-related issues continuing to repeat at intermittent intervals. Very common. So add in the mainframe, and there are additional challenges. They include lack of access, lack of visibility, and lack of skills. Not only is the mainframe locked away in an inaccessible data center somewhere, most IT professionals, even if they had access, would have no idea what they're looking at. Concepts such as batch processing, queuing, and time slicing are core to mainframe performance, and they're often the sources of application-related problems. So knowledge of these kinds of functions is important for resolving those problems. These are foreign concepts, however, to those from a Windows-centric world. When you add the mainframe challenges to the application-related challenges we saw on the previous slide, it's easy to see why DevOps becomes more difficult in mainframe environments. Tools can help. One key role of DevOps-ready tools is to fill in the knowledge gaps that are unavoidable in cross-functional support, since very few such teams have knowledge of every infrastructure element their applications access. And today, mainframe skills are at a premium. Tools can help bridge these gaps. However, product selections must be made with a clear understanding of the technology and application types in use at a given company. For example, relatively few tools have end-to-end visibility across mainframe and distributed technologies. So let's take a look at APM as an example of application-focused tools which raise a lot of questions. These tools can support cross-domain teams at virtually any stage of the application lifecycle. However, like DevOps, APM is another term that means different things to virtually every vendor. Both application performance monitoring and application performance management tools are often abbreviated as APM. While both focus on performance, one focuses on problem diagnostics as well. Monitoring tools can tell you whether the application is up or down and how well it's performing. They're useful for tasks such as SLA monitoring or for providing a point-in-time perspective on application health. Monitoring alone, however, doesn't pinpoint the sources of a performance problem. For this, you need application management tools, which also have some level of visibility to the application's technology underpinnings. True application management is all about instrumentation and analytics. It's in contrast to silo management tools because they must also be capable of synthesizing an ecosystem view of the application in context to underlying silos. Application management tools can dramatically reduce the time required to determine root cause, and mainframe-ready tools provide the visibility necessary to facilitate mainframe troubleshooting. These tools enable application support professionals with minimal mainframe expertise to more quickly determine when the mainframe is the likely source of a problem. They can then route it to people with deep mainframe knowledge. However, mainframe troubleshooting in and of itself, and even for these experts, can be very time-consuming. Visibility to the problem can help immensely in actually solving it. Compuware's application management solutions, for example, provide details and documentation related to mainframe application issues. Application performance management tools aren't just limited to benefits that you get out of production. They have value basically across the life cycle. During development and testing, the kinds of metrics that they generate can help identify and predict performance characteristics which may impact the application in production. Developers can then fix problems pre-deployment. At deployment, APM tools ensure the application has been deployed and configured correctly and that it delivers on contracted service levels. During production, application management tools monitor performance, notify on problems, help detect root cause, and help measure service levels for SLA monitoring. Finally, as applications are cycled back to development for modification, which they almost always are as business needs change, the data collected during the manage and assess stages of the life cycle provides valuable input for performance optimization at the code level. So I'm going to return in a few minutes to wrap things up, but at this point in today's presentation, Spencer and Jim are going to tell you more about Compuware's offerings in this space. Jim and Spencer, go ahead.
Thanks, Julie. And as I started to mention earlier, I'm going to walk through the Compuware DevOps solution and demonstration with the help of Jim. And so Compuware's taken an evolutionary approach as opposed to a revolutionary approach to our DevOps solution. So we've not, recreated the world. We basically took our best-of-breed tools and we've added some really simple integration between the tools. And so what Jim and I are going to do here is we're going to walk through, a typical scenario where an operations person may notice that there's an issue with a Kix transaction and then notifies the developer of that problem. And so for this scenario, I'm going to be wearing the operations hat, and the tool that I'm going to be using for that is our strobe tool. And it's our mainframe application performance management tool. And as you can see on the slide, these are some of the areas where Strobe is used to reduce the number of MIPS on your mainframes today. And so what we're really going to be doing today is putting out that fire. So we're going to be, probably the number one use for Strobe is fighting fires. And so we're going to walk through a scenario like that. So I'm coming in and I'm looking at my iStrobe report. It's called the Kix Transaction Summary. And what this report is doing is that it's taking all of the data collected by Strobe, it's summarizing it, and then it's comparing today's performance to past performance. And so looking at over 3 weeks of data, so from May 1st to May 21st, is the data that Strobe and iStrobe are reporting on, and then I'm comparing that data, so I'm benchmarking it to past performance. And when it benchmarks it, it has the ability to turn a box from green to red or to yellow. And so just by looking at this one report, I can tell whether performance is performance fine or is it starting to go south on me. And so if all the boxes are green, then I really probably don't need to do anything. There's other tasks that probably more important tasks that I need to be working on, as opposed to analyzing iStrobe profiles to see that performance is relatively, it's a flat line and there's not a problem. But by looking at this report here, I can see, there might be a problem here on this transaction AARB. iStrobe has turned the box red. So what I need to do is I need to drill down into this. And so simply by clicking on that transaction name there, AARB, I'm going to find out more information on that transaction. And what we're benchmarking here is the average response time for that transaction. And so I take a look at it, and what the Strobe Insight report is bringing up now, it's showing me all the different profiles that this transaction has showed up in. And on the right-hand side there, you can see what the average response time is, and it's breaking that down into the dispatch delay time, the suspend time, and the execute time. So instead of having to go through all 4 of these individual profiles to find out, hey, which one is the problem, iStrobe is pointing out to me that first one, the profile is called Bolts 2, and he's the one where the transaction response time was throwing off the average for all the others. Now, in this case, it's 4, so that doesn't really sound like a lot. But think about if you were to measure your Kix regions on a regular basis, which is what we recommend. Maybe you're to measure it 2 or 3 times a day. And instead of having 4 profiles here, you were to have 40 profiles. So you could simply, you would be much easier to find the problem instead of having to analyze all 40 of those profiles. So we're going to drill into this one right here, the Bolts 2 profile. And when we take a look at that, the first thing that we're brought to is called Strobe Advisor. And this is new it's one of our newer features in iStrobe. And what the Strobe Advisor does is it goes out there and it analyzes all the information in the iStrobe profile and then generates a couple of reports to show you, hey, where might the problem actually be? And so here you can see we have a problem in the user application. There's a module here called CCAA-DEME, and the section name is FLD-DB21. And I can see that the actual source statement there, it's a move function current date to a working storage variable there, date time, and that's using 7.35% of the CPU. So this was a pretty, CPU-intensive application to begin with, or measurement. You could see about 20% of the time it was using the CPU. We can see that in that big pie chart. And then the Strobe Advisor now is telling me that, hey, 7.35% of that, so almost 1/10 of that CPU is that one line of code. And so that's something that, as an operations person, I would love the developer to take a closer look at and figure out, hey, what's going on here? So in the past, what I might do is I might call up Jim and say, Jim, there's a problem here. Can you go take a look at at it. And then Jim would have to go out there and, step through the application, maybe put some displays in to figure out where, the performance issue might be. But now what I can do is I can actually tell him what the problem is. And on the right-hand side there, right above that brown line, there's a little icon. If I click on that, that's going to create what we call a fix request. And the fix request is going to gather some artifacts that Jim or the developer needs to actually debug this problem. And so I'm going to put some information in here. I'm going to give it a summary name. I'm going to say there's high CPU and FLD DB21. And then I'm going to put a description in there of what I've seen. So I copy and pasted in the source statement, and then I put in my own little analysis. Now, if we have I could very easily take this fix request and I could attach it to a help desk ticket item, so I could then, transfer it that way. Or I could simply, put this into an email, and I could send it over to Jim as well. So for the purposes of the demonstration, the quickest way to get this to Jim is just to email him. So I'm going to put this into an email. I'm going to put a little, verbiage about what I've seen here, as well as give him that fix request, and then I'm going to send it off to him. So I send that off to him, and now Jim is going to take over and figure out where the problem might be.
All right, thanks, Spencer. Now, as Spencer and I walk through this kind of real-life example, I just want to remind you of Julie's presentation where she was able to show a business value to the improved interaction across development and operations. And you have to believe at least some of that has to do with how damaging those all-hands-on-deck, war room-type meetings can actually be to developer productivity and then cascade up to the actual bottom line of your business. And, as this webcast revealed, problems are inevitable. It's how you handle those problems. That's the part where you can control. Now, Spencer was being operations, and for the rest of this demo, I'll be the developer. And in most cases, and people that have been in this situation know, the developer can often come in cold, very cold, just knowing the existence of a problem. So here what we want to show you is how this find and fix capability can give the developer a kickstart towards problem resolution. I should mention I'll be using the Compuware Workbench. This is our Eclipse-based, modernized interface into the mainframe. And you can access all of the classic Compuware tooling through here. You can get at common ISPF-type functions like accessing data sets and recalling data sets. You can submit jobs and review output. And then in some cases it also goes above and beyond. For instance, it offers some intelligent source code editing. First thing I'm going to do is I'm going to import that fix request that Spencer sent to me in our example. He sent it via email. And when I import that into my workbench, a couple of things will happen. The first is it will create what's known as a Mylin task. Now, Mylin is a time and task Eclipse-based open software product. And really, in our case, we're using it as a container to hold all of the information we already know about this issue. And if we take a look at the information that's made available to me, again, remember I might be coming in cold at this point, you can really break this down into three categories. The first is kind of the free-form text that the operations person, in our case Spencer, entered. And this gives him an opportunity to pass along some institutional knowledge about this issue. Right? In this case, he was telling me the program, and he actually gave me the line of code. And in some cases, this might be the one piece of information that allows me to jump to the solution. Like maybe Spencer might have said, hey, this seems to happen on Wednesday mornings, or this has been happening consistently since since the reorg failed, or something institutional that might trigger the solution. The second piece of information that's passed along in that fix request into the Mylin task actually comes from the product itself, and this kind of answers the who, what, where, and when kind of thing. So I can see when the issue was recorded, what LPAR it was on. Because this is CICS, I can see what region, what module, and what program. So this kind of clears up all those who, what, where details. And then finally, a third piece of information that's included in the Myelin task is a link back to the initial problem resource. And in this case, this is a link back to that same Maestro profile that Spencer was walking through. And, so if there's more information to be culled from that profile, I can get at it from just one click. And I should mention that we're walking through a performance issue, but had this actually been an abend, if the CICS transaction had actually abended, you can follow this same path with abendaid, and in that case, this link would take me back to the abendaid report to see the problem. All right, so now I can begin actually rolling up my sleeves and thinking of how to solve this problem. And at some point, all roads will lead to Expediter, right? Either, and this really depends on the inclination of the programmer, that, if I'm savvy about this application, I might be able to actually begin working on a solution, and then I would use Expediter to walk through my solution. Or if I'm a little more naive on this application, maybe I just want to walk through it to get a feel for what it does. So inside the Compuware Workbench, I'm going to flip perspectives to the Expediter perspective. And to initiate an Expediter debugging session, I need what's known as a debug configuration. And this is really the second half of that find and fix request, is that one's already been built on my behalf. So if you look at my CICS debug configurations, you can see there's one with that same summary name that Spencer gave the fix request. So this is a pre-built debug configuration to speed up my process to get into Expediter. So if I select that entry, first thing that happens is it pops up, and again it shows me that freeform text that Spencer entered, so it gives me the heads up on what Spencer saw as the issue. And then it also gives me an opportunity to modify any of the settings, right? It shows me where the actual problem occurred, and then it allows me to control where I want to run my Expediter session. Because remember, Spencer might very well have found this problem in production, and I might want to walk through it in test. So I might want to flip the LPAR to the test LPAR, or possibly keep the LPAR the same but flip it over to a test region. Conversely, Spencer might have actually found this problem as part of a QA testing, and in that case, maybe I can actually test on the exact same LPAR on the exact same region. So with that, I kick off my test, and I'm able to stop at the line of code and basically watch the program run to get a better feel for what it's doing when this line of code gets executed, right? There's nothing that brings more clarity to a problem than watching the code so you can see it in the context of the code what the problem is. And another nice thing about the Compuware products is, because we're all working off the same version of the listing in the DDIO file, all the line numbers match. So when Spencer told me the issue was at this line number, as I walk through it with Expediter, I can, the line number stays consistent. Another really useful tool for helping to get a grasp of what a program's actually doing, or in some cases what it's not doing, is Compuware's code coverage. And what this is this actually records what lines of code are executed during a session. And I can then look at the feedback to see how many times a line was executed, or perhaps whether it was not executed at all. And so if we flip over to look at the code coverage results of this test, and again, there's the line of code in question, and we can see something interesting if we hone down in a little bit. We can see that that particular line of code was executed 500 times. All right, so in my one simple transaction, that line of code was executed 500 times. So that already gives us a head start on what the problem was. We haven't actually fixed it yet, but we're well on our way. For one thing, the COBOL function, that current date, does it need to be in a loop? Do we need to get the current date in a part of the code that loops? And then probably even more pertinent, why is this paragraph executed 500 times in one transaction? And again, this is a CICS application, but it very well could have been initiated from the web. And if it's initiated, if it's available from the web, for instance, for your customers to use, this might be executing hundreds, thousands of times in a minute. And if for each one of those requests, if we're actually executing this line of code 500 times, you could see where it would suddenly have a significant impact on your performance. And that was really just a quick example. In Julie's talk, she was emphasizing the pragmatic. And so that's why we wanted to show you this find and fix capability, because it's so specific to the practical day-to-day improvements in a developer's interaction with operations. And I should mention that for those of you that are existing Compuware customers, these are parts that are all most likely already in place at your shop. And again, hopefully you'll take this as another indication of Compuware's continuous commitment to the mainframe. And with that, I'd like to pass it back to Julie so she can wrap up.
Thank you so much, Jim and Spencer. Great presentation and great demo of tools with DevOps readiness. So, basically what I'm talking about when I talk about mainframe support. So, in terms of wrapping up, while both the mainframe and DevOps deliver strong value propositions, they each introduce unique challenges that I've talked about today to cross-functional collaboration. On the mainframe side, it's frequently a matter of lack of visibility, lack of tool support, or lack of skills. On the DevOps side, it's often the case that processes alone are not enough. Manual processes and human knowledge really no longer suffice from the application management perspective. They're simply too slow to be practical for supporting modern high-velocity businesses. Supporting applications at scale requires tools-driven collaboration, particularly as transactions span traditional and mainframe platforms. Mainframe-ready tools, such as those provided by Compuware, give you the visibility necessary to reduce the time required for troubleshooting, root cause analysis, and remediation. And at this point in our webinar, I've concluded my presentation. We're going to open the floor up for Q&A.
Thanks, Julie. I would like to remind you, don't forget to fill out the survey before the end of today's presentation, and by submitting a response, you are automatically going to be entered to win a $100 American Express gift card. So while we're going through the Q&A, that might be a great time to work on the survey questions. So I'm going to open up the Q&A, and I'll be asking the questions and maybe answering a few. First question is, quite a number of vendors are using the term DevOps and continuous delivery as if they are one and the same. What is the relationship, if any, between the two? Julie, it sounds like a question for you.
And that's a really good question. I actually just finished up research on both topics, and from what I can see, I think DevOps is much more of an enterprise-centric kind of a term. Continuous delivery is actually being used for companies across the board who develop software and want to be able to release code on an ongoing basis. And in most cases at higher levels of velocity. But that being said, it's certainly something that I hear when I talk with software vendors, with software as a service providers, basically, with companies who are in business to deliver software, but, in some cases at least, not necessarily to host it for a business. Now, DevOps is much more of an enterprise-focused function, certainly something that is necessary to put software in production and support it once it gets into production. But they are related. I very much see DevOps as a framework or a basis for continuous delivery. If that those DevOps capabilities are in place, being able to speed up the delivery of software to the business becomes much more of a seamless process.
Thank you, Julie. The next question is this fix request process limited to COBOL, CICS, mainframe? Jim, do you want to handle that one?
Sure, and that's a good question because we kind of just ripped through the example without touching on that. It's not particularly language specific at all. It's just a process for instance, from either Strobe or Abendade to pass information to a programmer. As far as mainframe, it currently is mainframe. Now, again, like I mentioned in the presentation, the activity might be initiated off the mainframe, but this specific find and fix actually occurs with the mainframe part of the issue. And then finally, the thing about CICS, in our current release, the answer is yes, it is CICS specific. But we do have a new release coming out in the fall, and that's going to broaden the scope of this find and fix to batch, IMS, MPP, DB2 stored procedure. So it kind of opens the floodgates there.
Great, thanks, Jim. Julie, we have another question for you. Your research shows a strong correlation between revenue growth and the quality of the interaction between dev and ops. Why do you think this is the case?
Another good question. And, I mentioned some of the reasons actually in my presentation, the fact that, most companies are finding, particularly with, the economic challenges they faced over the past few years, most companies are finding that they really need to be able to get software out to the business faster. And I think in many cases, DevOps is something that facilitates this. If you are actually releasing software, you can release it as quickly as you want to. I mean, every minute of every day. But if you don't have some way to support it and to introduce some sort of discipline or governance to the process, it's really very difficult to have continuous delivery be successful. Everybody knows that high rates of change impact production IT, and that's another thing that my research is showing, that too many IT professionals really feel that they don't have that visibility they need to the changes that are happening. DevOps practices can help, and DevOps-ready tools can certainly help as well.
Thanks, Julie. The next question I think is for me. How do I get the iStrobe report that compares the performance of CICS transactions over time? That report is not generated in every single iStrobe profile. In fact, it's not generated in any of the iStrobe profiles. It's in a section of iStrobe called Strobe Insight. And so that's sort of our data mining feature of Strobe and iStrobe that looks at all your Strobe profiles that you've created, as well as looking at some SMF data as well. So within iStrobe, look for the Strobe Insight icon, and you'll see all the reports that are available to you there. Okay, the next question, again, is for you, Julie. DevOps is usually thought of as a set of practices and processes, not as a set of products. How important is automation in or to DevOps?
Well, since I spend a lot of my time talking about automation in relation to applications, obviously, it's kind of my biased perspective. But I try to approach these questions from the seat of a CIO or someone who is struggling to deliver services to the business. And in the complexity that we're seeing today, I mean, for example, something like 30% of the companies I talk to have already delivered transactions that span, on-premise and public cloud. These are complex transactions, and if you're trying to manage these by, without the right tools or with just silo-based tools and not application-focused tools, it's going to be very difficult. As you know, and I think you kind of alluded to this, throwing people at the problem is a very expensive way to do it. Getting everybody in the room like you used to just really isn't practical anymore. So tools can pull up a lot of that slack, and choosing the right tools can certainly smooth and facilitate DevOps processes across the life cycle.
Thanks, Julie. With that question, that brings us to the end of our webcast today. I'd like to thank everyone for joining us, and I apologize for the audio issues we had. Please don't forget to fill out the survey after the webcast to enter the $100 giveaway. And with that, Julie, thank you for your time and insights on DevOps, and Jim, fantastic job.